So it's your unit circle lesson. If you were absent, this is for you. If you just want to watch it again. The unit circle is built on two very special triangles. One of them is what we call the 45-45-90. And a 45-45-90 triangle has a pair of congruent sides, a pair of congruent legs, roughly the same length, and I'm just going to denote that with these tick marks that imply congruency. And what we do is we call them both x. Okay, now I'm going to do something old. I'm going to go off the side. I'm going to do a squared plus b squared equals c squared. Now, by the way, these are 45-degree angles. Angles lie inside, not outside. And because the angles are congruent, the sides are congruent. So let's see what happens if we do the oldest theorem that mankind has, Pythagorean theorem. If we do x squared plus x squared, we get 2x squared equals c squared. And just kind of lost my train of thought here. The next thing to do would be able to take the square root of both sides. Now, you cannot take the square root of 2, but you can take the square root of x squared, and that would create an x. So you get x roots of 2 is your hypotenuse. This is the same thing Ms. Cantrell taught you, okay? Now, I'm saying there's multiple variations that you can use. The two big patterns that we use in trig, this is the easiest one to do, but it's not necessarily the best one. It's 1, 1, root 2. Again, these are 45-degree angles. I do require you to label the angles, or the one that works best for unit circle is a hypotenuse of 1. And if you can glance over here, you can follow the logic. This root of 2 got divided out. So this piece right here would be 1 over root 2, and then you need to go back to Miss Cantrell's class about cleaning up the radical. You multiply top and bottom by root 2 over 2, and you get root 2 over 2, because 1 times root of 2 is root of 2, and root 2 times root of 2 is 2. And if one leg of a 45-45-90 is root 2 over 2, so is the other one. And again, I don't care which one you memorize. I really don't. It'd be awesome if you learned all three of them, because those are the three big patterns on a 45-45-90 that trigonometry cares about. But then you have the 30-60-90 pattern. The 30-60-90 obviously has a right angle. It's got a 30-degree angle here and a 60-degree angle. I completely did that. Yeah, that's right. 60-degree angle here. The 60-degree angle is opposite of the longer side. The 30-degree angle is opposite of the smaller side. Now, the small side is called x. The hypotenuse is literally twice the small side's length, and the long leg is x roots of 3. And again, there's other patterns you can memorize. I like to tell kids it's as easy as 1, 2, 3 with a root on a 3. And again, the small side is opposite of the 30-degree angle. The long side is opposite of the root 3, and the hypotenuse would be opposite of 90 degrees. Or the unit circle likes this one. Hypotenuse of 1. The short leg is half of that, and the long leg is a half times a root of 3, which I write as root 3 over 2. And most people do write that as root 3 over 2. So there's your two patterns. All right. There's some other stuff you need to memorize. Classic trig. Oh no, what has happened? We had a power outage. Hopefully it didn't mess up my recording. Hope it didn't. Classic trig deals with SOHCAHTOA. And we haven't got to the unit circle yet. There's just lots of stuff that you have to memorize. The sine ratio is the opposite side over the hypotenuse. The cosine ratio is the adjacent side over the hypotenuse. The tangent ratio is opposite over adjacent. Now, I've seen other people write it like this. This makes sense. SOHCAHTOA, written like that, because it tells you what it is. These three guys are what you call reciprocals. I completely misspelled that word. Reciprocals. Cosecant is a reciprocal of sine. Sine says O, cosecant is a ho. Secant is a funny guy. It's a reciprocal of cosine. It's a ha. Cotangent is a reciprocal of tangent. It says Ayo. That came from SOHCAHTOA. Now we have a circular approach to trig. In the circular approach, when you're actually dealing with the circular nature of our trig functions, the sine ratio is the y value on the circle over the radius. And this will make sense over the course of a couple days. It will. The cosine ratio is the x coordinate over the radius. The tangent ratio is y over x. Tangent is also known as sine over cosine. Cosecant is going to be the reciprocal of sine. It's going to be the radius over y. And again, r here is radius. Okay, because we're doing a circular approach. R is for radius. Secant is the reciprocal of cosine. It's r over x. Cotangent is the reciprocal of tangent. It's x over y. And r squared is literally x squared plus y squared. This is kind of a c squared equals a squared plus b squared idea. It's a ripoff of Pythagorean theorem. All right, now on to the circle. Oh, we'll come back to this in just a second. Let's get on to the circle. Now, I'm not going to let you use a calculator for this. The unit circle quizzes are rote memorization. Somewhere on your sheet of paper, there should be a blank here, the radius. It is called the unit circle. The radius is 1, okay? Don't get that wrong. Like, it's called a unit circle. The radius is 1. Come on, kids. We talk about rotation. If you start here, by definition, you haven't rotated. You're 0 degrees. 0 degrees as a pi rad, which we're going to talk about, a pi radian. Radians are just another way of measuring angles. It's kind of like doing feet and meters. That's all it is. But 0 degrees is known as 0 pi, okay? Now, if the radius of this circle is 1, then the x coordinate here is 1, and we haven't gone up or down, so the y coordinate is 0. All right, we're going to do some of the easy stuff first. You go over halfway around the circle, you have traveled 180 degrees, and that happens to be 1 pi radian. So 180 degrees is 1 pi radian. Okay, use that, all right? Let's go up here. We haven't gone left or right. X is 0, but the y value is 1. This would be a rotation of 90 degrees, you know, because you've done a quadrant. There's a right angle. If 180 degrees is pi, then this must be pi over 2. And by the way, 90 degrees of rotation. All right, let's start here and travel to the third quadrantal angle, which is right here. This is 270 degrees of rotation. And pi over 2 is worth 90. 3 times 90 is 270. It takes 3 of these pi over 2's to be equivalent to 270 degrees. The ordered pair here, we didn't go left or right. We just fell 1, so 0, negative 1. And now we start to get doing some of the fun stuff, okay? So, this slice of pie right here is worth 30 degrees. And I am going to imagine the triangle is right here. Because this is a 30-degree slice of pie, I have the 30, 60, 90 pattern, and I am using this pattern right here. This one right here, the last one I wrote. The radius of the circle would be 1, which would be the hypotenuse. The short leg is a half, and the long leg is root 3 over 2. So to get to here, not here, to get to here, I ran right root 3 over 2, and I rose a half. That's where those pairs are coming from. Root 3 over 2, and I rose a half. Now remember I said that that was 30 degrees? It was a 30-degree slice of pie. And let's think about this. I have 30 degrees out of 180 degrees. I'm using 180 degrees because it's a pie. 30 is 1/6 of 180, so a sixth of pi, or written pi over 6. All right, we're getting there somewhere, okay? All right, the next slice of pie is 2 smaller slices, okay? It's this one and this one. The big slice is worth 30, the little one's 15. You put them together and you get 45 degrees. Imagine a triangle is drawn. It's a right triangle. I'm going back and I am thinking about this 45, 45, 90 right here. That's the one I'm thinking about. So on that 45, 45, 90, both the legs are root 2's over 2's and the hypotenuse is 1, which it should be because it's a unit circle. All right? So to get here, I ran right root 2 over 2 and I ran up root 2 over 2. Now we're getting somewhere. This is root 2 over 2, root 2 over 2. And it was a 45-degree angle. And 45 degrees is equivalent to pi over 4, because if you take 180 and divide it by 45, you get 4. So pi over 4. The last one we need to finish this thing out is going to be a 60-degree angle. I've got plenty of circles here, and this is on purpose. But it's going to be right here. This is the imaginary triangle. And it has a 60-degree angle right there because each little slice is 15. 30 plus 15 plus 15 is 60. And now opposite of a 60-degree angle is a root 3 over 2. Adjacent or touching the 60-degree angle or opposite of the 30-degree angle in the corner is a half. So to get here, I ran right a half and up root 3 over 2. And I know that you're probably struggling like, what is he doing, man? Because you don't even want to remember that you learned 30, 60, 90 theorem once upon a time. And that's on you. That's legit not my fault. Memorize things and things will start clicking, okay? Now, this was a 60-degree angle. 60 degrees is 1/3 of 180. So this becomes pi over 3. And again, this was a 60-degree angle. Now, what you've done is you have completed quadrant 1. And quadrant 1 is the most important quadrant. The rest of it is more or less about symmetry and just basic number sense. We're going to use symmetry to figure out the rest of these points. These 2 points right here have symmetry. But the x value would be negative because you're in quadrant 2. It's the same height, so root 3 over 2. The next 2 things that have symmetry are here and here. X is negative. So negative root 2 over 2, y is positive, positive root 2 over 2. Again, x is negative, y is positive, root 3 over 2, and it is negative, positive 1/2. I don't know why I didn't fill this one out earlier. You just went back 1 unit, you didn't go up or down anything. All right, still using symmetry, I'm going to follow the diameter of the circle to the other side. Now in quadrant 3, both things would be negative because x is running left and y is falling. And again, I'm going to follow the diameter and use symmetry. Both negative, okay, because you're in quadrant 3. Follow the diameter, use symmetry. And when you get to quadrant 4, you can be symmetrical with quadrant 2 if you want, or you can be symmetrical with quadrant 1. Just look at the x values, a half, root 2 over 2, root 3 over 2. And the y values are going to be the same, except you're down here. You're below the origin, so they're going to be negative. Negative root 3 over 2, negative root 2 over 2, and then negative 1/2. All right. The only thing left I really have to do is finish out degrees. Now, remember that a big slice is worth 30. 90 and 30 is 120. A little slice is 15. Add 15, you're at 135. Add 15, you're at 150. I'm not going to let you push buttons on a TA84, because if you can't add 30 and 15, I personally don't think you should be allowed to breed. But that's a personal opinion, and I'm not in charge of things like that. 180 plus 30 is 210. 210 plus 15 is 225. 225 plus 15 is 240. Add 30 to 270, add 30 here, 300, add 15, 315, add 15, 330, add 30, 360. Now remember, pi is 180, so 360 is twice pi. And that, boys and girls, is the unit circle. Your goal is going to be able to do that and a little more in 5 minutes or less, and that's the time frame I allow. Now, there's one more thing, and again, it'll click when we get there. These are the signs in certain quadrants. And I'll type this out for you, and you have to regurgitate all of it. Now, I use an acronym here. I've got lots of them, and I'm not gonna put the one that I say in class on YouTube, but the acronym is All Schools Torture Children, okay? All schools torture children. You're in quadrant 1 is where the A comes into place. All trig ratios are positive. You're gonna have to write that out, okay? Quadrant 2 is the S. In quadrant 2, sine and its reciprocal cosecant are positive. They're the only ones. Everything else is negative. You get down to quadrant 2 is where the T kicks in. Tangent and cotangent are positive. And the last thing we have is C. The C is for cosine, and its reciprocal secant are positive. Everything else is going to be negative. And if you put all that together, you have the unit circle. And everything you need to know, by and large, about elementary trigonometry. And that is your unit circle lesson. It's the unit circle I teach here at Dresden High School in Tennessee. I push a lot of stuff on there. I have a lot of good luck with it. I can tell you that we're actually not done with the circle, for one. I need to be done with it. I didn't finish it, did I? I forgot about my pi rads. You can tell I'm tired. I've been working trying to get the STC thing going. So I know that 120 degrees is twice a 60. So this is going to be a 2 pi over a 3. Okay. I know that it takes 3 45s to be 135 because I have some number sense. So it's going to take 3 of them pi over 4s. I know that it takes 5 30s to be 150, so it's going to take 5 of them pi's over 6. And I can use that same process for everything, like 210 degrees is equal to 7 30s, right? So I could just kind of say 30 is pi over 6, 7 pi over 6. Now, there's also something else you can do, and it works very, very well. This has an understood 1. 1 plus 6 is 7. 7 pi over 6. I'm going to follow this diagonal. Understood 1. 1 plus 4 is 5. 5 pi over 4. And look, I just shot across the diagonal. I'm going to shoot across the diagonal. 3 plus 1 is 4. 4 pi over 3. And it even holds up here. 1 plus 2 is 3. 3 pi over 2. Shoot across the diagonal. 2 plus 3 is 5. 5 pi over the same denominator of 3. 3 plus 4 is 7. 7 pi over 4. And the last one, 5 plus 6 makes 11. 11 pi over 6. And there, now I'm done. That's the complete unit circle. Sorry I forgot about part of it. My mind is literally elsewhere. But memorize this thing, and it will pay dividends, okay? It's a big deal in trig. Lots of kids who go into STEM majors say, "Thank you, Milbrath, for forcing me to memorize the unit circle." There's not a whole lot of kids that do that anymore, but they still say thank you, and you're welcome.